recording live. I'm too busy getting pizza and coffee.
Live. Yes, it is live.
Thank you.
Okay. Thank you very much. Really appreciate it.
Hello everyone, just want to get some pizza.
Yeah, you two managed to hold out.
Oh yeah, I grabbed something to eat on the way through. So I was on over there, sort of.
All right.
Maybe you can get us so just like more.
That's impressive. Yeah.
But I like it as
So,
well.
I mean, we've
I
had
wouldn't mind a slice myself. You know, it'll be gone by the time I finished it.
When he's not here, you can always just think.
He won't notice.
And he might come back in and kill you if he catches you, I don't know.
So welcome, by the way, new face, good to see. Tom's about to say this, but you've sort of dropped in at an odd time because we're starting again from scratch on the 1st of May. The 1st of May?
Yeah.
Whatever the Tuesday is.
Okay.
So you've come right at the end.
Okay.
So we're having like I don't know what your sort of level of knowledge is of C++.
Very little.
Okay, so this is sort of a revision session for everything we've done so far.
Okay, that'll be interesting. Then I can start properly.
But 1st of May,
You're welcome to stay.
But of course,
Oh, I'll stay,
yeah. But just to warn you, if you sort of this is your first time, and you go, what the hell is this? So we're going to be going over things pretty fast today because it's revision.
Do you know existing programming?
I have been developing in C# for the last year or so.
You won't find this.
Okay.
Straight away, 3 people within 1 minute.
Excellent.
Okay, welcome everybody. My name is Tom Breza, as most of people I hope will know by now. Today we have our 25th, and this is one before last meetup for this course. And on the 1st of May we are starting a brand new course. It's a very exciting thing because we will be based out on our book. So if you're interested to start from scratch, sign up to our course and we can get it from there. The good news is, as of now, let's open the website. As of today, for the new course, we have 168 people sign up. I'm not kidding. 168
Yeah, we're going to
people.
need a bigger room.
I suspect most of these people are online.
Well, where do we sign up?
On our CPP London Uni. So www.cpplondonuni.com, and then if you go to RSVP, just click on the 1st of May, new course, and then you have a picture of the book by Mr. Bjorn Struct, which we'll be using as a base for our syllabus. So we advise people to buy this book, and obviously it will be very useful when you will start going through the course.
It's available as an ebook
If you want to. Personally, I prefer the physical book, but some people might prefer ebook.
So the RSVP, you say?
Yes, and obviously as well. Later on as well, as normal, for those people who join us as well, whether you're online or physically here, on the Skills Matters website as well. So this way they see people coming. Clearly 168 people put the interest, so...
I think
No.
I think we can thank Jacko for a lot of those. I think you...
Yeah, I suspect. I don't know what made it. I know Phil Nash done a lightning talk about us as well, so that could help as well.
At CCU?
I think so.
Oh, right.
So another nice thing is after this class there is a 26th class which will be the final class, and on that final class we have 2 very exciting things. Number 1, everybody who wants will get a project. Then they have approximately 8 to 12 hours, of coding for the project.
So we'll give you a week. You can spend as long.
But the project, so for example, if you sit, you should be able to do it within 8 to 10 hours. But we give you like a week to complete that. Don't worry, I'm as everybody else. I will not be treated in any kind way. So these guys.
Tom doesn't even know what it is.
Yes. it's on a side of the project. Yeah, I have only one person who sent me the suggestion. Yeah, so please can you email me suggestions of the project, because for these guys it will be easier to make the more project suggestions that we have, they can share those among us. If not, then obviously it's harder. And the second nice part of the last meeting, we will have a class which was supposed to happen a few weeks ago, but it didn't happen. Phil Nash will talk about catch.
Oh,
Yes.
Yeah.
So that's all from me. Thank you very much. I really appreciate.
Catch is a testing framework for C++, very widely used, and we're lucky enough that the author, Phil Nash, who runs the main C++ London meetup, is going to come and talk to us. So
He's like a godfather to us.
Yeah, we got him to thank for this.
So without much of ado, I'm passing you to Tristan.
All right. Good evening, everybody. Again.
Hello.
Right. So slightly different this week, because we're drawing to the end. We're going to restart in a couple of weeks. We've got a special session next week. So there's no new material this week. What we're going to do is we're going to do revision, and what I want to know is I want questions from you. So I've got very sort of basic slides with some just revision notes that may be useful, but really I don't want to be standing here talking for 2 hours like I did last week, which,
It was a good test for you.
yeah. I really want questions from you, and then we can have some back and forth, and I can demonstrate some things actually with the IDE, with the compiler, and and yeah, basically we want to be here to fill any gaps that you feel you have in your knowledge. So, standard first slides. Please join the Slack channel. Those people who haven't, talk to us whenever you like, and also if we have any announcements and things, we can put it on there. There is this assessment next week for those people who want to do it. We may be, if we find bugs or people have questions, that'd be a really good forum to sort of distribute all the information about that. So please do go and join the Slack. Okay. Today's lesson plan. Revision, and then if we get to the end of that, we've got this noughts and crosses exercise, which the really old timers, so Tom and Lauren and Joshua, who were here right back in week 4, might remember this.
Thank you for mentioning which week.
Who might remember this exercise. You guys have had 21 weeks of more learning since then, so you can have another go at it for the rest of you who are newer. You can have a go at it. May or may not be useful for the assessment. That's all I'm going to say. All right, so moving on. Let's start with some revision notes. Initialization, which is really complicated in C++. Probably more complicated than I've communicated here, but luckily most of the time you don't have. There are only really 2 cases you have to worry about. And the first is fundamental types, so things like int. They're not initialized by default. If you just say int I, semicolon, that does not have a value. This value is undefined. Attempting to read from an undefined value, an uninitialized variable, is undefined behavior. That's bad. Undefined behavior is what the C++ standard says. Anything can happen. Your program is not valid C++. The compiler can, as the saying goes, you can have demons fly out of your nose, or it can format your hard drive. It can do whatever it likes. All bets are off. Unfortunately, doing whatever it likes often includes doing exactly what you intended it to do, which makes it sometimes hard to diagnose undefined behavior. There are a couple of contexts in which you are guaranteed that it will give you an error. If you're doing this in a const expr function, we haven't talked about const expr in this course, but it's a way of doing computations at compile time. In other circumstances, you may get a warning for using an uninitialized variable, but you may not. Golden rule, always initialize your variables. Golden rule. May or may not, may be the most important rule that I give you today. So that was for types, fundamental types like ints. Okay, those aren't the only kind of types we have in C++. The other really important one are class types. So things like standard string, standard vector, things, basically things with constructors and private member variables, classes, right?
What does it mean on aggregate class?
So an aggregate is a special kind of class which doesn't have constructors and doesn't have private bases, doesn't have private member variables. It's basically like a C struct. And an aggregate, you initialize its members in curly braces, and you initialize all its members. It basically exists in C for in C++ for compatibility with C, and it actually causes some problems. And I wish I'd get rid of them, but we're stuck with them. Most of the class types you'll deal with are non-aggregates. So if you just do struct and then int x, int y, so it's no constructors, no private, no nothing, just a basic struct, that will be an aggregate. Most of the time you don't have to worry about it. I just put that because otherwise this statement is technically incorrect. I just, you know, there are some very pedantic people who will pick me up on it. So if you just write standard string s, because string has a default constructor, and it's not an aggregate, it will be default initialized. The default constructor will be called, the string will create an empty string for you. Unfortunately, it's not really obvious what's a non-aggregate class and what's not. If you don't want to go through your, look at every type you use from somebody else's library and decide, well, okay, is this okay to just write without an initializer or not? So the golden rule, always initialize your variables. That way you're safe. Whether it's an aggregate, whether it's a fundamental type, whether it's a class type that has a default constructor, always initialize your variables, no matter what.
I was going to ask a question.
Yeah, sure.
Should one, because usually when we initialize a variable, we use the equal sign. But should one make it a habit of using the new curly brace sign, or just so that everything is just kind of uniform like that?
Yeah, that's what the curly brace syntax was called, it's uniform initialization syntax. So my habit is when I've got something like an int or a float, it seems somehow more natural to write equals whatever, int I equals 3. For other things like strings and vectors, I'll use the constructor syntax. Now, that's just me, it's just a style thing. They do, however, do slightly different things in that if you use the equal syntax, that will not consider explicit constructors. Okay, so you remember we talked ages ago about implicit and explicit constructors. Explicit constructors don't generate an implicit conversion. And also you can't use explicit constructors when you do equals thing. So in general, for simple types like int, I personally will use the equal syntax. If you want to, for consistency, you can use the curly braces. The one thing you have to be careful with the curly braces is that for certain types like standard vector, there is a different meaning if you use curly braces or if you use round brackets, which is really, really annoying. Really annoying.
It is initializing with one is to give the size with the default value, and the other is to as initialize at least.
That is precisely it. Yes, well done. Yeah. So for technically something that has an initializer list constructor, which vector does, if you use the curly braces, then you supply a list. So you do standard vector, curly braces, 1, 2, 3. And if you use the round brackets, then it will look for other constructors. And vector has about, I think, half a dozen different constructors. One of which, like you say, you can supply a default value and the number of elements and things like
For
that.
example, if you do vector 5 with curly brackets, is a vector which only has one element, which is 5.
Yes.
If you do with a round parenthesis, is I think a 5 integer value 0.
Five default constructor elements. Value constructor elements, yes.
Can I
Yeah.
just
Yes.
for 1 second? A little bit of good news. We just found with Ollie. I posted the info about our new course on isocpp.org, and we are being featured in training session as a top post. So
Fame at last. Right, we're definitely going to need a bigger room. Yes.
The brace initializers, does it do a standard move or standard copy?
Does it do?
Standard move or standard copy?
Well, that's a good question. So you were here last week, so maybe you can tell me. What are the requirements for it to do? If you don't think of a constructor, think about a regular function. If you just had foo brackets and you pass it a value, right? If you pass it an R value, it'll use the move constructor if possible, if the type has one. If you pass it an L value, it'll use a copy constructor. So it's right at the other end of these slides, which we'll probably talk about, in an hour or more. I go in more detail about move, a bit of revision from last week. So if you use the curly braces, it depends on the thing you put in the braces. If that's an R value, it'll use move construction. If the thing you put in there is an L value, you use copy construction.
If you use a mix, use a copy of it.
So if you move some of them, and then it depends on whether there's an appropriate constructor that takes that mix of L values and R values. But again, I will tell you all about that in a while. I wish I had something to write on. I've got a feeling if I write on this, it's never going to come off again. So unfortunately, the board is at the back. But yeah, we'll go into a lot more detail about move and copy later. Keeping it simple first.
Use a massive force, right?
No,
I think you can just leave the
I don't think our board has a way of playing it out.
Yeah, don't worry. I've got the ID set up. I can flick to that because then people who are watching the stream can see what I write as well. Don't worry about it too much, guys. It's okay.
Sure,
Yeah,
we'll get it. It's fine.
He's committed now. He's
Yeah.
invested.
Now we've started. We may as well finish.
I think I have to get up.
Excuse us while we rearrange the room.
Being killed by a microphone is not on the top 10 list of things to die by. Chat for the, yeah. Okay, we are.
Okay, now.
Yeah.
and now you need to pen.
How does this hang?
There's a hole in it.
The other way round, yes?
There's a hole puncher.
Yeah.
And I'll get it.
That's got it. I've got it. All right. Now it's a whiteboard that I'm probably not going to use for the rest of the time. Where were we? We're talking about initialization. Let's talk about auto. So C++ 11 didn't introduce the keyword. The keyword was already there, but it meant something different. C++ 11 changed the meaning of the auto keyword to mean type deduction. Initialize, declare a variable, and have its type deduced from its initializer. Auto is great for a few reasons. One of the reasons auto is great is that if you use auto, it's impossible to forget to initialize a variable. Can you think why that might be?
Type reduction.
Type deduction, exactly. If I just write auto I with no initializer, the compiler is going to say to me, well, what type did you mean here? Right? I've got no initializer to try and deduce the type from. So with auto, it's really handy. So you can, for example, write auto I equals 3, and I will be deduced to be an int. Or you can write auto I equals standard string brackets hello world, and your string will be deduced to be, your auto variable will be deduced to be a string.
Then why there is so much debate online on using auto, not using auto? I see there are quite a few look and stuff like,
So some authors, in particular, there's a famous blog post by Herb Sutter who coined the term almost always auto. That he argues in this blog post that you should use auto to for almost all your variable declarations.
why people which are contrary, what is their argument?
So the counter argument, well, it's this. So the counter argument is that if you use auto everywhere, basically you're trying to be too clever. You know, the compiler knows what the type is, but it's not obvious to a human reader what the type of this variable is. And that it hides too much information.
Function return type is the best example. Because if you're calling a function, it returns something.
Yeah, well, that's bad for two reasons. It's because in the calling context, it needs to evaluate the look at the function definition to work out what the return type is. So it's even more expensive on compile time there.
On compile time is more expensive, but then in performance, if one compile it is the same.
The runtime performance will be the same, yes.
Okay.
So yeah, the contrary opinion is that it makes the code unclear. So it's a bit, if you're familiar with C#, auto is like var, like it deduces the type. I don't know whether people have these debates in C# about whether it's better to explicitly write the type you're expecting. But yeah, these debates go on and on in C++. There's no real, people still argue about it. There are situations where you have to use auto. So if you're dealing with, with lambdas, lambda's an anonymous type. That is, only the compiler knows its name, so you have to use auto in that situation. And there are other examples where everybody agrees that auto is nice. If you do auto iter equals vec.begin, nobody is arguing that you should type standard vector int : const iterator. That would be silly.
Sadly do exist.
Sorry?
Those people sadly do exist.
Those people do exist. Well, they're wrong. So yeah, this is, I'm not telling you to do it one way or the other. I'm presenting you with both the arguments and letting you work it out for yourself. What I will say is that C++ 14, Ollie touched on it, it lets you use auto as a function return type.
Sorry, I was thinking that, you know, when you know explicitly what's the return type or what the type of the variable, you should use the type of the variable. But in a situation where it's dubious or you're not sure, then it's better to use auto. Wouldn't that be a sensible approach?
That is pretty much this fourth bullet point.
Okay. Cool.
The other example, the other opinion that I didn't put on here is that if you are expecting a function to return a certain type, and you use the fixed return, you declare a variable, you know, of my type A equals this function. If somebody then goes and later changes that function, so it returns a different type that is not the type you're expecting, you'll get an error. Whereas if you use auto, your code is suddenly, you're going to get an error somewhere else because it will have deduced it from the new function return type that wasn't what you were expecting. So there is a correctness argument in there as well. Again, I'm not really sure that I buy it, but those are the arguments. But as far as, yes, so you can also use auto as a function return type, and that means that the return type of the function is deduced from the return statements in the function body, which can be really useful for prototyping stuff, but in that situation my advice would be generally to avoid it. And the reason for that is that it tends to be more expensive in compile time, because whenever you use that function, the compiler can't just look at the signature to work out what the return type is. It needs to actually evaluate the function to see what
So
it might
only
return.
during the compilation time that would have impact.
Yes, and it's also easier for people who are just reading your code. You know, if you're looking at a header file and you see auto function brackets arguments, that means you have to look at the function body to work it out as well. Whereas if you just see the signature.
What if there is a situation where you will receive some sort of data and you don't know what is the return type? What will be going back?
Well, in that case, you can use auto. I mean, you can use auto almost everywhere and let the compiler deduce it. And then when things go wrong, you're going to get a mess of error messages that are possibly quite hard to decipher. And C++ is infamous for those anyway.
Yeah.
So,
I mean, I'm referring now to the latest tutorial from Kate Gregory, and she says, she's fine if something slows down the compile time, if that improves the performance of the program, because you'll do the latter, you will do much more often than the first one.
Oh, absolutely. So if you can, templates are a good example. Templates, especially heavy template metaprogramming, will slow down your compilation. Sometimes, a big C++ program can take tens of minutes, if not hours, to compile. But you get absolutely stellar runtime performance, and that's a trade-off that's worth it, because you generally run a program many, many more times than you compile it. So something like that is fine. What we're talking about here, though, you don't get any runtime benefit from using an auto function return type, auto return type for a function. It's not any faster at runtime.
Okay.
However, the code then is less clear to readers and potentially gives you worse error messages. So,
but would you care if you use less readable? Because anyway, the compiler is your friend, so you actually rely part of the job to the compiler.
Yeah.
I think we're talking about two competing aspects. There's maintainability of your code. So if it's just your pet project, then you don't care about anyone else probably, and that's okay for you. If it's writing software at scale, then you do have those issues where you need a team to be able to work on it, and it does need to compile in a sensible amount of time. So generally speaking, if you're scaling up, then you start to care more.
But wouldn't you then have like rules on, okay, we will apply, this auto, let's say, in such situations, but in others, like, wouldn't that go under the guidance of the?
Some people do it. I mean, you can have a rule that says no template usage, but it's probably a bad idea. Usually, it's in agile businesses anyway. The approach is that you don't have hard and fast rules. It's not like set in stone. You cannot do this, but you can do this. It's more a case of you can do whatever you want, but when it comes to review time, you're also expected to sort of say, "Have a look at this" early on, rather than just right at the end. And people obviously give you feedback, and so, because if you use any new feature of the language, but others in your team can read it and they like it, like it's idiomatic, great. So setting rules can be good, but it's more than usually slightly.
One question: if you have an auto return type and you have a switch statement that returns different types within the function, what will happen?
That will be an error. So what it does is, the first time it sees a return statement, it looks at the type it's returning, and says, okay, that's the return type of the function. And then if it comes across another return statement further on, it checks to make sure that's the same.
We have a question. Is auto an overhead?
Is auto an overhead? It's not a runtime overhead in any way, shape or form, no. No, your program will have identical performance whether you use auto or whether you explicitly write the type. Wait a few seconds to go through.
So far so good.
Yeah.
Maybe one thing to note is, say you had a function that returns, say, or I think I'm correct on this, but let's just go through it. So say you had a function that returns a reference to a string, stood string, and you had your original line of code was stood string ampersand equals all function. So that function returns a ref. If you do auto whatever equals and then function call, will it not copy?
Yeah, so the other point that I think I talked about way back in week 2 or whenever we first introduced this, is that auto never deduces to a reference. Auto is never a reference. Right, so if we have, yeah, you're using it.
Auto on its own.
Yeah. So we've got this function getIn that returns us, that looks like int8, it's supposed to be int for f. And then later on in the code I do auto I. So now I'm deducing the type of this variable I from the return type of this function. This function returns a reference, but also never deduces to a reference. So this will always be a copy of I. So if I want to have an automatically deduced reference type, I have to make it clear. I have to write auto and I equals getIn, like that.
Alternatively, auto and.
Yeah. Well, I'll go on to say later that you probably rarely want to,
But
almost
if
never want to
you
use
do
that.
that in a first instance, would that give you the compiler error, or would it convert?
No,
to
because that's
that?
fine, because an int is a copyable type.
So you take the copy.
Yeah. If this returns something that's not copyable, something like a unique pointer, then you would get a compile error, because it would say you're trying to copy it, but we can't copy it. So auto is great, I use it a lot. Some people argue that you shouldn't use it a lot. So this is a matter of style. I'm not telling you to do one thing or the other. It's up to you. The only hard and fast rule I would say is if you're working on somebody else's code base, be consistent with their code. But that's not C++ specific. That goes for any programming that you do.
Or just your own code, really. Be consistent everywhere.
Yeah, exactly. So that's a very brief revision. I'm literally got a couple of slides for each topic. So that's initialization and auto. Everybody happy? All right, let's move on. Special member functions. This is a test for you. What are the special member functions?
Constructor.
More specifically,
Default constructor,
default constructor, yes.
destructor,
Destructor,
copy constructor,
yep,
move constructor.
yep.
There are 6.
Assignment operator,
Yeah, right.
yeah, 2 of those. Copy assignment and move assignment. 6 special member functions. Why are these called the special member functions? What's special about them? What makes them different to ordinary member functions?
Because they serve this specific language semantics.
Sort of. There's something else that makes them more special.
Well, they are the standard API for a class of constructor.
I know it.
Ollie knows what I'm going. What I'm getting at is that if you don't write these yourself, the compiler will write them for you. That's why they're special. Except this bullet point isn't quite right. It's a little more complicated than that, because this is what I said last week. If you write your own copy constructor and copy assignment operator, the compiler says, okay, you're doing something special, so I won't generate the move operations for you. And vice versa. If you write a move constructor and a move assignment operator or a move assignment operator, it won't generate the copy operations for you. But if you don't write any of them, then you get all 4.
You get all of it, or just 2?
All of them.
Another little tidbit related to that is the destructor, if you declare your own, or even if you don't, is implicitly no except. So if you declare a destructor and you throw an exception, you will just terminate the program.
Never throw an exception from a destructor.
So you should never do that. You should never do that anyway, but in the event that you have some incredibly special use case that really, really justifies it, which I would scrutinise heavily, then you need to explicitly specify when you declare your destructor that it will actually throw, or you'll just crash.
There's one more little addendum to this that I didn't put on the slides, but if you define any other constructor other than a copy and move constructor, any other constructor that takes a value the compiler won't generate a default constructor for you, which again is generally generally what you want. The other reason special members are special is that if for some reason it's not going to be generated automatically because, you know, let's say you've written your own copy constructor and copy assignment operator, but you know that the default move will be okay, you can explicitly request it with this equals default syntax. And equals default also works for the default constructor as well. So that can make life easier. So to do that, you write your signature and then equals default and then a semicolon. So
also, probably should point out that simply doing equals default won't actually make it come into existence if it's suppressed by something. So if your class had a unique pointer as a field, unique pointers are copyable. You can happily go off and say, oh yeah, const my type and equals default, but it's not going to do anything because the fact you've got to move only type in your class means the compiler cannot generate it. It will still be valid code, it will be compilable, but if you have any code that then tries to exercise the copy operation, you'll fail there.
Oh, so you fail one time?
no.
No, not right. You still fail at compile time. So
Oh, right.
attempting to use that constructor will fail at compile time. But declaring it is not an error.
I think probably the better way of putting it is if you write it as equals default within your class definition, it will only spring into existence when somebody tries to use it. Right? Otherwise, the compiler is not going to bother polluting your code, your executable output.
It's a type that physically cannot be copyable, and default won't physically get.
So that's what makes special members special. There are 6 of them. I talked about this last week, but just to go over it again because it is an important rule. If you use a non-default version of any of the special members other than the default constructor, so any of the other 5, destructor, copy and move constructor, copy and move assignment, if you're doing something special in any of those, you probably need to do something special in all of them. Right, so that's the rule of 5. If you write 1, you've got to write 5.
If I write a constructor.
No, if you write a copy constructor.
Oh, sorry. Yeah. All good.
I like this one much better. The rule of 0. And that says it's better not to declare any of the special members and just let the compiler do all of them for us. Much nicer. And the best way to be able to enable that is to use smart pointer types, use things like vectors. Basically, don't look after resources yourself. Have a class that encapsulates this, and then the move. If you have one of these as a member, the move operations, the copy operations that the compiler generates will do the right thing, and you can skip writing your own copy and move constructors, and everything works well. Rule of 0 is absolutely preferable, always preferable. So, oh yes, so smart pointers assist with being able to do this yourself. Those are special members. God, we're racing through this, sort of.
Is that the am I correct that the raw points are being like pushed out more? You know, people being persuaded to go towards the smart pointers.
Smart pointers and raw pointers, which I thought was the next section, but it's not. They serve different purposes in C++, in modern C++, so 11 and newer. And we'll get on in a couple of slides' time to talking about exactly when you should use smart pointers and what raw pointers are good for these days. So hold fire for about 5 minutes.
Okay.
All right. Any more questions about special member functions before we move on? Oh, excellent. Right. Operator overloading. By the way, what I did is I literally went through all our past notes and I tried to put on one slide for every class we did, which boiling down a 2.5-hour session to one slide is it's not easy, so I've skipped quite a bit, but
so far so good.
Yeah, this is why I wanted you to ask questions. So operator overloading. You can overload almost every operator in C++. There are 3 exceptions that I know of, which is the dot, so doing x dot y, so member access.
You cannot overload dot.
You can't overload dot. There is a proposal. Jan Struct wants to let you do it, but it hasn't.
Well, why would you want to do that?
Because it lets you, we have smart pointers at the moment, and if you can overload operator dot, you'll be able to write things called smart references.
Oh, I see.
However, it's a lot of controversy, and basically you're not allowed to do it at the moment. It's not going to be in C++ 20, or it's highly unlikely it'll be in C++ 20, so don't worry about it. So you can't overload dot. What's called the scope resolution operator, the double colon. Thank goodness you can't change the meaning of that, because that'd be a nightmare. And also the ternary operator, you know, the question mark colon, you can't overload that. Not for any particular reason, but apparently it was just because they couldn't work out the syntax and nobody really thought of a good reason to do it. Almost so every other operator can be overloaded, including daft things like the comma.
Oh.
Yeah, the comma operator, which you're doing that, which I presume you're talking about user-defined literals.
Yeah.
Yeah. Another thing we haven't talked about in the course, but you can, if you write a literal, which is either a string literal, which is in quotes, or a character literal, which is in single quotes, or a numeric literal, which is a number in your source code, and then after that you put a particular suffix, you can define how the compiler interprets that literal.
Must start with an underscore.
User ones must start with an suffixes must start with an underscore. This is useful because it lets you do kind of cute things. So if you write hello world in quotes and then put an S after it, if you include the right things from the standard library, this will have type standard string. So usually without that, it would have type const car 12. With that, array of const car, array of 12 const car. With the S, it turns it straight into a standard string for you.
But you also have to include using namespace to
Yeah,
literals.
yeah. There's you have to put another line in your code above this.
So is that an operator?
It's a user-defined literal operator, I suppose. Yes,
That's
you define it in your class as I can never remember the exact syntax.
Return type operator quotes.
Operator quotes,
And then
the name,
name's going to be,
and then the arguments.
and then type is going to take.
Yeah.
Oh, where does the S go?
So,
The definition of
so somewhere in your string header, it will have a line that looks like this with S in there, and then this will be const car.
Ah, I see.
There are only specific forms of arguments that are acceptable to this. Again, I can never remember them because I rarely write these things.
I'm trying to just return this because I'm trying to put that for the.
All right, let's write it out neatly. So UDLs. So you have to write this line. So using namespace standard literals, that's should be on one line, I just can't fit it on there. Right, and if you do that, then you can write auto struct equals so if you do that, and if you do auto struct equals hello with an S on the end, that is type standard string. Yeah.
You overload the semicolon operator.
No, it's not an operator.
Also, if you're using the chrono library, you
Oh,
use
yes.
it on a number, it being second.
Oh, of course, yes.
Also, if you don't want to use all literals willy-nilly, you can include the specific ones. So you could use using namespace string underscore literals, or using namespace chrono underscore literals.
yes.
So it turns out that what the list guys say is actually true. Within every language, there's a very awful
Half of common. Yes. Yeah. And that was said about Fortran 50 years ago, and it's still true.
Yeah, but then what do people use this for?
Yeah.
Well, that doesn't actually matter because I don't think it's what it's used for. It's more a lingua franca for programming languages.
Yeah.
That's the power.
You try and use metatables, you can do very, very silly things.
That's the only data structure in Lua, isn't it?
Hmm?
Isn't a table the only data
No,
structure?
it is, but you can do what's called metatables that let you do weird things. So I just did a silly Lua script where you could take like the word 1 plus the word 5 and you'd get back 6. So it was pretty
It sounds like crazy JavaScript stuff there.
Once you get into metatables in Lua,
Yeah.
it's ridiculous.
Anyway, what are we talking about? We're talking about operator overloading. So almost all operators can be overloaded. The most common, we've already talked about it, is operator equals, the assignment operator. That's the special one. So I say it's the most common. That's true, but you want to avoid it, we just said. What you really want to do is let the compiler generate that for you. Probably the other most common ones are operator equals equals, which compares two things for equality, and a corresponding not equals.
Can anyone think of a sensible reason to make equals equals do something different? No, not be the complete inverse of not equals, or vice versa.
There is no good reason. No.
Also, equals equals is generated by default.
Not in C++ 17. So in 20, in some circumstances, you will get it by default.
How about the spaceship?
That's the spaceship operator, yeah. But to be honest, I'm not quite up to date with the proposal, so I can't really say too much about it now, other than for normal classes, you will get equals equals by default in 20, which will be lovely.
What's the spaceship operator?
Yeah, exactly.
Less than equals greater than.
Yeah. It's a way of writing all your comparison operators in one go.
Right.
And it,
Does it supposed to work like in Ruby, which returns it compares two things? If one is lesser than, you get -1. If it equals 0, and +1.
I believe so, yeah. Like I say, I'm not 100% up to date with it yet. I don't think it's available in any compilers to play with yet. So I read the paper, but I can't remember much about it now. So I can't say too much about that. But it will be there. It's been approved for C++ 20. If your class has value semantics, and what I mean by that is basically if it's not a polymorphic class, if it's something that if it looks like an int, right, or behaves like an int, that is
means not having many forms.
Exactly. Well, specifically, I mean, virtual functions and things like that, and derived classes.
It's not from a hierarchy of types.
Yeah, exactly. So if it's just something like a vector or a string, or a type that holds a collection of these things, if it's not part of a hierarchy, it's probably a wise idea to implement operator equals equals. And if you do equals equals, you really need to do not equals as well, because otherwise people will hate you. You can also implement the remaining 4 comparison operators, less than, greater than equals, less than equals. If you do those, you can use your type as a key in a standard map, which is nice.
You need less than.
You only need less than, but again, this is another thing. If you do less than, you should really do the other 3 as well. Because otherwise it's going to be really unexpected. If I can ask if A is less than B, I should really be able to ask if B is greater than A. Which leads me, actually, onto the golden rule for operator overloading. Don't surprise people. If you choose to overload an operator, then make it do the obvious thing. Basically, make it do what ints do.
Composer operators like lesser than or equal, greater than or equals are composed or needed to declare them separately?
You need to, at the moment, you need to declare them separately. Yes.
In the future, instead?
This spaceship thing will let you generate them all at once.
Default object. So if you want the functionality, you have to declare the spaceship operator as default.
Yeah.
Then you get everything for free. If alternatively, you can just overload it yourself and do whatever you want.
But really, the absolute golden rule for operator overloading, because C++ lets you do pretty much anything in an operator overload, right?
Is there a way that we can imitate the spaceship operator on our own now? Not by creating, obviously, all of those by hand.
I would say don't worry about the spaceship too much. We're getting distracted talking about spaceships.
Yeah.
That's for the future.
Okay.
This is for today, right? If you're really interested, look at something called standard relops, but don't, because nobody uses it. And that's what the spaceship operator is going to replace. Anyway, golden rule, don't surprise your users. Follow the usual semantics for an operator. So let's say you've got a mathematical vector of 3 values. So it's got float A, B, C, or float X, Y, Z. This is a mathematical vector, not a standard vector. It's perfectly reasonable to implement things like plus, operator plus. But it'd be very surprising if you wrote an operator plus and what it did was multiply 2 things together. That's gonna be crazy, right? So follow the usual conventions, right? If you write operator equals, make it return a bool, make it just compare the members of your type.
And be const correct.
Yeah.
That's one of the biggest bugs you can unintentionally do as well is have a comparison operator or something that shouldn't touch anything and accidentally modify something. If you are const correct, then you're not going to be able to compile if you accidentally find such a bug. And that means it's not going to be horrible things that you why did this whole suddenly change?
Just one dumb question.
Yeah.
When you overload things like plus, minus, all the mathematical operators,
Yeah.
should they follow the algebraic rules of math or it don't matter? Like as 1 plus 2 is 3 and 2 plus 1 is also 3. Or does
Well,
it, does it
Because a string, for example, would be
Yeah, so addition doesn't have to necessarily be commutative, that's what you're saying. So for example, floats, everything uses IEEE floats. Those technically, addition is not commutative, multiplication, because you can get rounding errors. And let's say if you're writing a matrix type, mathematical matrix type, then obviously multiplication in general is not. Yeah. So, but of course, if you're doing something like I was talking about, a vec3, you'd expect a plus b to give you the same result as b plus a. It'd be surprising if it didn't. So, yeah, operator overloading. Don't be stupid. That's probably the rule for operator overloading. Do what people expect. It's a really useful tool that can make your code much easier to look at much easier to read, because it's far more obvious if you just see a plus b. That makes it easier to read in most circumstances than, add vector brackets ab, particularly if you nest many operations.
Is there any common pattern where people actually mess up? The overloading where... Yeah,
there's one very well-known example of somebody doing something very, very unexpected with an operator overload, and that's IO streams. So one of the operators is this less than,
yeah.
bit shift. So for an int, that's the bit shift operator. Literally messes about with the bits. But it's overloaded for IO streams to do this thing of shifting the thing on the right into the stream on the left. So you do standard out, bit shift operator, thing. Which, according to the rules I've just written, is not a good use of operator overloading. And I think you'll find a lot of people agree that what IO streams do in many ways is not good examples of modern C++. But IO streams was written in 1983 or something, so the rules weren't quite as well established then. If we ever get a replacement for IO streams, I very strongly suspect it won't use the bit shift operator.
Also, maybe it's useful, but I think of operator overloads as just syntactic sugar for a function call.
That is exactly what they are, yeah.
So when you see an operator being used, it's some function call really that's happening. Which is
So if you can avoid them, avoid them.
No, I wouldn't say that. Use them where they make sense, where they can make code more clear. Does that sound right?
Yeah, I agree. Yeah, they can help you make things much more idiomatic. If you, I don't know, if you've got a class of like several integers and you want to be able to add class A and class B so that you get class C with the addition of all of those fields, it's convenient, right?
Yeah.
So you don't have to write something obvious, just the more ones every time.
I mean, it is something that a lot of people dislike. So Java doesn't have operator overloading, as far as I know, because it does. Oh,
It's true.
it's true. But not general. You can't define plus for.
Java
Two.
is an operator.
Yeah, exactly. So
String concatenation is using operator.
okay, but that's a built-in type in
That's
Java.
special. Strings are special, but you
Yeah, there's so many other special types.
yeah,
Anyway.
you can do it, you can't do it. As a
The
Java
point is,
developer.
some language designers go, operator overloading is evil, it hides what you're doing, we don't like it, we won't do it. C++, we say, okay, you can do operator overloading. In fact, C++ lets you do pretty much anything. So as writers, authors, we have to rein ourselves in and only do sensible things in operator overloads. Whew. Right, moving on our rapid fire 2-hour tour of the whole of C++. Not quite all of it. Inheritance.
It's the base class of all people.
Yes.
Very good, very good.
Yeah, so if you don't know, that's the talk, the title of a well-known talk by Sean Parent. I don't know if that's where you got it from. So he presented this thing called inheritance is the base class of evil, base class of all evil. And he presented in that talk a technique for doing runtime polymorphism with value semantics, which was, I don't know whether he invented it, but he certainly popularized that technique. And it's sort of taken off.
So is that does it mean, in his opinion, inheritance should be avoided?
Yes, he very explicitly says that in his talk. We're not that, what's the word, dogmatic here. Inheritance is a useful tool. Object-oriented programming isn't dead, despite what, if you go to a C++ conference, if you watch the talks online, you'll see nothing about object-oriented programming, because everyone's fixated on doing these clever new template techniques and writing these new libraries, and that's great. But object-oriented programming is still useful for a massive class of problems, and often it's the easiest way to do things. C++, I said this months ago, but it gives you a really large toolbox, right? So the joke about Java is that everything looks like a class hierarchy, because that's the only hammer you've got is object-oriented hierarchies and all that. Where C++ gives you a really large toolbox, and part of the part of the skill, part of the thing that comes from experience of using C++ is knowing which is the best tool for which job. And there are still jobs for which OOP is the best tool. So particularly if you have types that naturally form a problem where things naturally fall into a hierarchy. Virtual functions, polymorphism, runtime polymorphism, that sort of thing, still really useful. My personal opinion, don't ignore it just because it's not fashionable.
All I'll say is I think it's good. I think that these are just secret C programmers trying to sabotage us. It's extremely useful when it comes to unit testing. Having interfaces and plumbing implementations into each other for interfacing is invaluable, because it means that when you are unit testing, you can mock things really easily in a very high code confidence because you need to test it well, and then you just plug stuff into each other and watch it fall apart. That should just work usually.
So, perhaps the biggest use of inheritance, the best use of inheritance, it allows you to separate the class's interface from its implementation. Right, so you write an interface class, and then you can have many different implementations of this. You might have a test implementation that just, prints debug strings, doesn't actually call out to the internet or whatever. And then you have your real implementation, and you can test your code against the debug implementation. A little notes: structs default to public inheritance, classes default to private inheritance. There are 3 types of inheritance, if you don't remember: public, protected, and private. Protected inheritance is pretty much useless as far as I know. Public inheritance is what you want 99% of the time. Private inheritance is basically used as an optimization, so don't worry about it too much.
Should you use more inheritance or friend?
Or friends are a special case.
Yeah.
I generally say use friends when you're going to have a class that is not going to be exposed to whoever's using that particular class, right?
Mm-hmm.
So you have implementation A, you want people to use A, but maybe for some setup or in order to, monitor some field of that implementation, you want a friend because for some reason it doesn't organisationally make sense to just stick in that class. Then yes, fine, have a friend, but ideally don't expose that friend in the header somehow. So usually the common idiom to achieve that is, say, pointed to implementation. So you have your A and A impl, and then A impl would actually have the friend, and everyone who's using the library just sees A.
So the argument about this is what they call encapsulation.
Yes.
Right? So information hiding. So you're not depending on implementation details of this thing. You're just seeing the interface class.
So what would...
And what friend does is it punctures a hole in encapsulation.
Well, you can't make omelette without breaking eggs.
Right.
So for looking for the code maintainability over the time and security, would you prefer to use inheritance, or do you, you have a choice, yes, you need to access some of the stuff inside a class, yes, through the other class. Would you then go to the route of inheritance?
Okay, well, using a friend is a bit like using a cast, like static cast or something, right? If you do it a lot, it's a sign that you're doing something wrong. But sometimes it can be useful. So a static cast, punctures a hole in the type system. It's saying, okay, I know better than you, right? I'm doing something special here. And a friend is the same thing, right? So friends, definitely useful, probably shouldn't be overused.
I can probably give a decent example. So I have...
Do you want to put it on the board?
Just a question.
Yeah.
When you're writing iterators to your container class,
Yeah.
you need a friend. You need friends in that context just want to get access to the guts of the container class so that I can iterate over it efficiently. You don't have to.
No, for something like a
So
vector iterator, it's possible to write it. So it's possible to write it without having to make it a friend.
What if a class that a container class that has a node? The nodes are sort of...
Yeah, so if it's a member class, so remember you can nest classes, so you can find a class inside another class.
Yeah.
That inner class has access to private
Okay,
things,
right.
so you don't need to make it a friend in that
So
case.
it don't separate the iterators from the container class itself. Have it nested.
I don't want to say that as a general rule. I guess the general rule is probably avoid writing your own iterator types generally, because it's really hard and tedious to do, as I tried to get you to do it a few weeks ago. You're generally better off using one of the standard containers, and then you can just, if you want to implement your own begin and end, you can just forward the iterators that the standard container gives you. Okay.
So this is a rough example of where I've actually genuinely used friend in a sort of, I think, sensible way. So in this particular case, I had this thing I'm going to call a communicator, which was a library I was using. I didn't write it, and it was not within my power to modify its semantics. One, because I don't want to have to maintain it, and two, it wouldn't be practical. Within that communicator, we have two states. We're either in an open state, where we're sort of negotiating whether we're going to actually become active or not. And then if we did become active, then obviously within my program's representation, I wanted to go to my active state. So I had a class represent open and class represent active. We don't go back from active, it's just a simple by state. Once you're in active, either it's just going to stay alive for some period of time, and eventually it's just gone and it's over and you throw everything away. So the behaviour in open is completely different from the behaviour in active. The actual activity that this does, because the communicator expects you to implement an API, says you have to provide one set of functions, one consistent set of functions, and they do one thing when you're in the open state and a totally different thing when you're in the active state. So I could have alternatively just said I'll have one single class, and it'll, I don't know, track a boolean to know what state it's in. But then I'm going to have one single class doing everything, and it's going to be quite large. So a simple way of doing this, at least in my opinion, what I thought was simpler, was the communicator was instantiated in the open state class. This object lived as a field, as a unique pointer. And then we had I forgot the manager, so there's a manager here. Okay, so you've got your manager, which will allocate the open state. And then, if we're happy, then we go back to the manager, who will then start one of these up. This will take the instance of this, and because it's a friend, it says, thanks, I'll have your communicator. And then this just gets destroyed, and this carries on with the unique pointer to the communicator. Yes?
Why didn't you just use the memory function and try to communicate?
That is actually what it did. It was a private member function. So in here, I had a private member function that returned it. I didn't want it to be public, because the only thing that should be able to take it is him. No one else should be doing that, or it will screw things up.
I think I lost it. Would you mind? Because I'm not sure what each of these components are. Are they classes or?
So this is
So external by meaning external class.
no, yeah, effectively, yeah. This really represents a whole library. There's a class there that I instantiate. Yeah. Anyway, I think I'm done hijacking your.
Oh, that's right.
Sorry, I just want anything for Austrian operator as well?
I'm sorry? Yeah, so yeah, that can be a useful and valid use of a friend, is implementing something like an O-string operator overload so that you can write your type out. That's a perfectly valid use of a friend, yeah. Because of the way it's written, it can't be a member function. It has to be a free function. So yeah, that's perfectly valid, yeah.
I just thought technique had changed.
No. That's yeah. You're absolutely right. I forgot that. That's also friends. Yes, can be useful for writing other things like the operator equals equals I was talking about. Often you want to compare private members, so you have to make the operator equals equals either a member function or better make it a free function but a friend.
Just
Yeah.
one more question I just remembered I was going to ask. When you implement operators, do you want to do them in the class or outside the class, which is
In class or out of the class,
Yeah.
for operator overloads.
overloading?
Yeah, so there are some operators that must be member functions.
Right.
So that's the square brackets operator, the function call operator, round brackets, operator equals. I think the arrow operator, I'm not 100% sure. Basically, there are some that must be member functions. So obviously, those are member functions. For the other ones, what are called unary overloads, so things like the arrow, or things like operator star, dereference operator. The unary ones, those ones I would say probably better as member functions. Binary operators, so operator equals equals, not equals, greater than, less than, those are generally better written as non-member functions. And the reason for that is because it allows conversion of the left argument, which I can go into if you want me to. Yeah, okay.
I would say prefer member function. Prefer doing it in the member function, unless there's a particular case where you either can't, or that's about it. If you can't, then you can't. Otherwise, just I prefer it.
Isn't the syntax clearer if you do it out of the class?
I would argue no, because again, with the whole, I'm making the argument of supporting the concept of encapsulation here. If you think the encapsulation's crap, then obviously my argument is. But in terms of encapsulation, if the class itself implements those operators, it's got access to all its fields, it knows everything. If you're going to put it in a free function, then either that means your class is going to have to make its stuff public or declare the free function as a friend in order to get at it.
Yeah.
So there may potentially be cases where that doesn't matter, but I'd say they're fairly few and far between. And maybe if you're doing stuff where something's static, you can only get one instance and you roll with it. Oh no, even then it makes sense. So no, I don't think there's many cases where you want to.
Yeah, let's go back to inheritance, or what we were talking about. When we get to structs default to public inheritance, classes to private inheritance. That's one of the two differences between struct and class. What's the other one?
Public and private, and they don't have protected, yes, the struct?
They don't, they can have, can you have non-default constructors for structs?
You can, yeah, absolutely can.
Also, struct is exactly the same.
So it's related to public and private as well?
Or members?
Yeah, exactly.
Members are generally.
Visibility, yeah, default.
So by default, your class members of a struct are public and the members of a class are private. So there are two differences between class and struct in C++. So if you're coming from C#, for example, class and struct mean quite different things. They have quite different semantics. C++, they're almost identical. The only difference is default visibility of members, default inheritance. So this, we've just been talking about this, but in large projects, even in small projects often, separating implementation and interfaces is just kind of good engineering. Improves testability. For big projects, it gives you sort of ABI safety, so you don't have to recompile your whole projects. Compilation firewalls, they call them.
Sorry, can I ask them? Wouldn't it make sense then to remove structs, or I don't know, because class seems to be more popular in use. So
Well,
like,
yeah,
they
do we
keep
really
saying
need
why-
both of them?
why-
Probably
why?
not. Probably, so struct was inherited from C. Did we need the class keyword? Probably not.
Class or struct?
Sorry?
Class or
Well,
struct?
we had to have struct because of C compatibility.
Yeah, but I think, is it C++ not on that stage that we really don't care about?
No, because you
C?
still want to be able to use C headers directly. That's still a big selling point of C++. That you can.
I think there's a place for both of them very simply, because I generally use struct when in my head I've immediately gone, this is just going to contain, it's going to be like, usually it's going to be an aggregate, right? 9 times out of 10 I'm just writing an aggregate. Occasionally I'm not, but it's generally when I'm thinking to myself, okay, this is something that I'm going to have access to everything on. It doesn't need to have the implementation details, it's like super trivial, etc. When it's not, I use class. I do kind of break that rule because by that logic I should use struct for interfaces, because they just contain
Public stuff.
pure virtual member functions, but class builds more enigmatic static.
Yeah. Yeah. We don't need two separate keywords. No. Had Struct decided in 1979 or whatever it was that struct was all we needed, then it would be perfectly fine.
That feels like twice amount of the code, yes, twice amount of ways where you can make a mistake.
Well, it's not necessarily making a mistake.
Semantics are very specifically different.
I don't
You're
think
doing different things. You're saying different things when you say class and class.
they're not put down.
The semantics are the same, other than this default private and protected.
I mean,
But what you're saying is the intention you
Yeah,
are
the
communicating
intention.
with your code, yes, that by convention has come about, that if you use class, your type is it's somehow more complicated. It perhaps has virtual functions. It has what we call an invariant, perhaps, that it maintains. Whereas a struct typically is used for what is called plain old data, just a bag of data.
So if I would use some, let's say in a code, class or struct, would that be considered, like, I don't know, big faux pas or some sort of...
No, I wouldn't say so. In fact, for my code I write, unless I'm doing it for other people, for just stuff I do by myself, I use structs pretty much everywhere because I'm lazy, because it has better defaults. But as I said, be consistent with other people. If you're writing code for a library that uses class, use class. Personally, like I say, I'm lazy. I just use struct everywhere. So.
I put it this way: if you're just messing around and it's really just for you, then who cares? Then you want to use struct if you like. If, however, it's going to be messed with by other people, then I always suggest defaulting to using class for anything that's going to have stuff that you don't want other people mucking around with. Because then you're defaulting everything to private. You're only going to expose what you want to expose. And people aren't going to be mucking around with things that they should not be.
Okay.
Also, why I don't like using protected for that very reason too much, because if someone sees protected, they take that as an invitation to derive from the class so they can get at something inside it that probably shouldn't be, or that they'll probably misuse horribly and start wondering why things are crap. So use protected sparingly as well.
Again, a lot of these things are questions of style, right? So it's opinion based rather than actual fact.
Use cases.
Yeah, but there are ways of, like, you write codes, let's say if you have lots of experience with C, you can, people are like, look at your code and say, oh, you're writing very much like in C style, and not C++, and they are a better approach from, let's say, C++ point of view. And now we jumping on your experience, because you can make some of the undesirable design choices which later on might backfire. Yes, like, I don't know, using instead of using vector, going towards let's say something else, and
But that has nothing to do with the choice of class and struct.
Yeah, but I was giving like a general idea. Yes, the reason why we're probing, yes, from different angles, is to get, what would you get in the real life? So let's say you work for company A, and you're coming out, you're jumping, oh, we should use struct everywhere, and they look at you like, don't be daft. Yes, we'll be using class, and there are very good reasons for it.
Yes, yeah. Because in many code bases, like I say, like Joshua said, the choice of class or struct communicates something about the intention of that type, what it's meant to do. What I'm saying is that from a language perspective, there's almost no difference.
Okay.
So from a strict, according to the rules of C++, it pretty much doesn't matter which one you choose. But yes, the intention of the code, what you're communicating to the reader is perhaps different. Right, multiple inheritance. Multiple inheritance is allowed. You probably already knew that. A lot of OO languages don't let you, Java being the most pertinent example, although I think someone told me they'd added it to Java 10 or something.
And what?
Multiple inheritance.
I'm not aware of that. It got var. They did add var to it.
Yeah. Anyway, it doesn't matter. Because C++ does let you, and today we're talking about C++. See, multiple inheritance, a lot of people ban it outright. They say, no, don't do this. Right? And the reason they say don't do it is because it can get you into trouble. In particular, there's a problem they call the dreaded diamond, which is where you have, I'll write it on your board. So we have Class A, Class B, Class C, Class D down here, that's a D. So, this is not a diamond yet.
So that's not, yeah, that's
Not a diamond yet. But what happens if we have B and C that both inherit from this thing A, and then we've got this down here D that multiply inherits from both B and C.
That's fine, you can't compile that.
Yeah, we're going to. So now the problem is we have 2 copies of A in there. We have 2 copies of A's data, if it has any. If we try and call any A methods, it's going to say, hang on, which A did you mean? I've got 2 copies of the A base class in there.
Link.
Sorry?
That just wouldn't link. You won't even get a program out of it.
Oh, but can't you scope it using the intermediate types?
Shouldn't the A
If
be in the middle?
you have 2 different A's,
Yeah.
just make that first A go to C, imagine the other one's not there.
Like that.
Yeah, that's the diamond. Now wipe out the other one, that's a boom, diamond of death. Imagine A's.
But couldn't that be an actual design where you actually want 2 actual different values?
So it might, and it's a horrible. Sorry.
No, go on.
It's a horrible. No, I mean you could, but I can't think of any sensible reason why you'd want to do it.
You are
Also, because, I mean, so the problem is one, knowing which copy you want, and I'm going to say this, but please don't use it unless you really know what you're doing. Virtual inheritance. You can resolve the
That's
issue.
what the red pen is for.
Yeah, with virtual inheritance. If B and C declare, if you do B colon class B colon virtual A, and they both do it,
You are resigning
then
from your job,
then you
and then you leave somebody else to deal with that.
then you find the nearest window for you to defenestrate yourself from it.
But what if you can't update B on C?
Then if you're stuck with someone else's crappy code, then that's just life. On the other hand, if you entered into the project and you were trying to refactor and you discovered some crap like this, you just had to get it out the window, out the door rather, then hacking, just doing virtual inheritance is a quick way to resolve it. You've got no choice for that.
So there is something, as we say, called virtual inheritance. If we replace these with red arrows to signify virtual inheritance, if B and C both now virtually inherit from A, then D will only have 1 copy of A in its hierarchy.
So you just said don't use virtual inheritance.
Yes.
Well, I mean that in terms of design. Just don't make a diamond of death.
Okay.
So what I'm saying is don't make a diamond of death, don't also think, I'll make one and use virtual inheritance to fix it. Just don't do it.
So, but I read somewhere always, if you're going to use inheritance in C++, always use virtual.
Virtual
That's not
inheritance.
quite the same thing. So there's 2 directions you can go.
Always inherit virtually, effectively. Always
Well, you always inherit virtually.
Yeah.
I would say don't, because that introduces
I've heard the
costs.
argument that if you're inheriting pure interface classes, so classes with no data, then that is a valid use of virtual inheritance, because it means that later on you can inherit from another class that also implements that interface, and you can re-implement that interface by virtually inheriting directly from it. That I've heard that advice when you're dealing with pure interface classes. Yes, virtual inheritance is okay. I would say if you're dealing with base classes with data members, be very wary about using virtual inheritance. It's often a sign that things are getting too spaghetti-like and complicated. So, but as I say here, pure interface classes. So what in Java or C# you'd use the keyword interface. So these are classes with only, well, they don't have to have only virtual functions, but typically classes with pure virtual functionality that must be provided and with no data members themselves. As in Java, it's okay to implement multiple interfaces. It's a good thing in many respects. Same in C#. So it is in C++. If you're doing object-oriented stuff, using multiple inheritance with pure interface classes is okay by me. Not that I'm the ultimate arbiter of these things, but
no, I agree. Multiple inheritance of pure virtual interface classes is perfectly reasonable.
Yeah.
And very useful.
so the rule to ban multiple inheritance, I would say, is far too restrictive. What I would be wary of is doing multiple inheritance of base classes with data members. All right. Virtual functions. How do I write a pure virtual function in C++? An abstract function, as it should be called, as they call it in other languages.
I think virtual function say equals 0.
Brilliant.
Yes.
Yeah, absolutely. So you write your function, say void foo, and then you do equals 0. Oh, and I have to make this virtual as well.
Funnily enough, in the new standards, why don't they change that to null PT? That would make more sense.
So that's a novel. That's quite a novel idea.
I've never actually thought of this
Yeah.
as being, oh well, hang on, this is a function pointer in a
You
way.
have to add it. You'll get to replace
Yeah.
it. So you just break everyone's code.
I actually think they should add a soft keyword that is abstract, like they did for override and final, but
There's a quiz question. What happens if you declare a class and you do that? So you got virtual void foo equals 0, and then you provide a definition of it anyway outside of the class.
let me demonstrate.
That's it. That's fine.
Well, when you provide the definition, do you put the scope?
Yes.
So what happens if what will happen if you inherit from?
If you inherit from that, you still have to provide your own definition.
And if you inherit from it,
You still have to override it.
it's enough to
So you can use pure virtual to force inheritance, but you can still create a definition for that, and a derived class will be able to call it in order to execute that base class.
Yeah.
What's after class?
Class C.
Curly
I
brace.
couldn't think of a good name. Class C, curly brace.
You can use emojis in C++ now just to do a little smiley
Class smiley face.
pilot things.
Yeah, namespace part of foo. Yeah.
When can you use with the C++ emoji?
So what you're saying is it's legal to provide a body for legal to provide an implementation for a pure virtual function. Yes, it's legal, but it's very unusual. It's a trivia question more than anything else.
Yeah, sorry, I should have pointed out that there's probably not really any good reason to it.
Right. Anyway, Josh is absolutely right. You write a pure virtual function abstract method as a function signature followed by this funny equals 0 thing. A class that has a pure virtual method can't be instantiated directly. So if we tried to say, let's ignore this for a minute. If we had this class, if we just did C val like that, if we tried to declare a variable of type C, the compiler would say, no, you can't do it because we've got a pure virtual function. If we tried to make a unique pointer to C, by make unique, it would also fail.
by make unique.
Yeah, so well, more generally, if we said, auto P equals new C, right? So that this is kind of what make unique does under the covers. It calls operator new. That's not going to work because this is pure virtual. That's not going to work as well either.
But we can have a unique pointer with C as the template parameter.
Yes, you can. In the same way that you can form a raw pointer to an abstract type.
It has to be C pointer.
Oh no, because you need PTRs too.
Or reference, yes. Yeah. So if you are, this is new in C++11, there's this keyword. It's only a keyword in this particular context. In other, you can have a variable named override. But, always use it whenever you're implementing a virtual function. Trust me, you'll thank the committee for putting it in, because if you don't do this and you get the signature wrong, you're going to accidentally declare a different member function. And if you use the virtual keyword as well, you're accidentally going to declare a new virtual function. And you won't get the behavior you expect. Whereas if you say override, the compiler will check that you are indeed overriding a virtual function. Always use override. There's also something missing from this. Absolutely. So my definition of class C here is not a good one, because it also needs to have, really should have called it something other than C, but there we are. Needs a virtual destructor, so virtual tilde C. And then what?
On that note as well, the one case where having a definition for a pure virtual makes sense, you can define the destructor as pure virtual. Sorry, you about to say that?
No.
Oh, you can define the destructor pure virtual because, say, you have a class you do not want anyone to ever instantiate. And say, because it has virtual methods that are actually implemented. You don't want anyone to ever instantiate it, it needs to be private. You can declare the destructor as pure virtual and then have a separate definition underneath so that it will actually not crash or fail to link rather than most platforms, etc.
So you want to give it a virtual destructor, and here, just good practice, we said it's equal to default. That means, what does equal default mean for a special member? Please, compiler, will you generate this thing for me? Absolutely. So if your class has at least one other virtual method, always write a virtual destructor. Final. I don't think we talked about final. It's not particularly useful. It comes up occasionally, but it's possible to mark a class as final. Right? If you were to do it, you'd say class or struct, the name, and then you write the word final in here.
It does have a use of the optimizer.
So the word final appears after the class name, but before the curly brace. Again, keyword final is one of these funny things that's not really a keyword, but it is in certain situations. You can have a variable or a function named final if you want, but in this context, if it appears just there before your declaration of any base classes, if you have any, this means you cannot inherit from this class. Any attempt to inherit from this class is a compile time error. Now, as Ollie just said, this can sort of be useful in that it helps with what's called devirtualization. So if you've got virtual functions and a class hierarchy, and this virtual function is implemented in your base class, in your derived classes, then if you declare your last derived class as final, it means that the compiler knows that this virtual function isn't going to be overridden anywhere else. So in some circumstances, it can help it can use that information for optimization. It can inline that definition or something like that. Unfortunately, marking a class as final can be a pessimization, the opposite of an optimization. It can be a bad thing to do. For example, it prevents it being used, prevents something called the empty base class optimization. I've said this, it's probably best to avoid it in general. I think that's because most C++ code I've seen doesn't use doesn't use final. The other thing is that in general, you don't know what other people want to do with your code. It may be that someone has a valid reason to inherit from your class that you haven't foreseen. And by marking it as final, you are forbidding that. You are saying, you know, I know better than this person. Yeah, in general, most C++ code I've seen written since this came in doesn't use final. So, but it is there, and I thought I'd tell you about it. The other thing is it's possible to mark individual methods as final. So you'd write virtual void foo final. So the same place you'd write override, you write final. In fact, you can combine both of them.
But isn't declaring a type final, is that not the same thing as declaring a variable const?
No.
In a semantic sense, you're specifying.
I know where you're coming from.
Yeah.
The thing is, you are in control of your variables, right? So, in general, if you're writing a library, marking your classes as final, you're making a decision on behalf of the users of that library, saying it will never be useful to override this class. And I think that's the main argument that people have against final. Within your own private types, absolutely go ahead. Your own, private library, absolutely go ahead and use it if it's going to be an optimization, if it's going to help you out, if it's going to prevent mistakes. Absolutely go ahead and use it. But I would say if you're writing a library or code for other people to use, probably err on the side of caution.
I mean, there may be a case for it if you've got protected types. So you've got like A, B, C. Right, so A is the base, C is the top. A's got a protected member, and then B does something with it, and then C does something with it, and then there's no reason for anything else to touch these protected members. And again, you should be sure, depends on what your exposure should be. But if you want the buck to stop with C, to make it final, and then that protected stuff can't be messed with just by inheriting again.
Yeah.
Well, isn't there a rule that you should inherit from things like standard vector and standard string?
Yes.
Yeah, that's what you use final.
So they're not marked final, no. As far as the language goes, it's legal to do. The compiler's not going to bark at you. The reason we say don't do it is because those types don't have a virtual destructor. Right? They're not intended for polymorphic use. So if you write a type called myVector, which inherits from standard vector, that is perfectly legal. However, if you pass a pointer to a standard vector that in actual fact points to an instance of your class, and someone deletes that, then it's not going to work properly. It's not going to delete the members of the derived class.
But isn't that a good reason to use final?
Final will solve it. When you come to deleting the object, if at that point in the code you think the type is stood vector, then you will dispatch to the destructor of stood vector.
Yeah, I know what you're saying. You're saying to prevent mistakes, you could mark it as final.
Break existing code.
Yes, well, it might break existing code.
I just point out code that shouldn't be written.
I mean, it's
Yeah.
existing shitty code.
On the other hand, it's another thing of trying to say, well, I know better than you.
Yeah.
But we do, in the sense that if you don't have a virtual destructor, you're screwed. Well, you're not screwed.
No, because there are ways of using the code safely in spite of not having a virtual destructor. You just have to be very careful. You have to avoid deleting it through a base class pointer. So I have written messy code where I've wanted effectively a strong type def, and I've inherited from, privately inherited this is, from...
That's okay, that's in your own code, you know what you're inheriting.
Yeah, well the other thing is market class final prevents private inheritance as well, not just public inheritance, prevents any inheritance. And if you have a private base class, nobody can ever get a base class pointer, so you can't be deleted through it. So using a private base is fine, and final prevents that. So using a standard vector as a private base would be a fine thing to do. And final will prevent that. Yes. Oh, we're really getting into it, aren't we? This is good. We're I don't think we're going to get to the end going at this rate. This is brilliant though. Yes, you can also mark individual methods as final, has the obvious effect of preventing you from overriding them. Let's move on. Pointers. Everybody's favourite bit of C++. What is a pointer? This is not a rhetorical question. Somebody tell me, what's a pointer?
Pointer is pointing to the address. It points to the address in the memory, which is occupied by something or not.
Pointer is a value representing a memory address. That's all it is. Right? It's not magical. It's not really all that special. It's a value. It's a bit like an int that holds a number, and that number is the address in memory of something else.
Is it useful to think of it as a tuple?
As a
Tuple.
a tuple?
That it's a value that has two values, one the memory address and also the value in the memory address.
I have not heard that before. It doesn't immediately make sense to me, sort of semantically.
You would call it a pair in C++.
A pair, yeah. I would say no. That's
You're pointing to the address, yes, not to the value that's held by the address, but you can only access the value of that which is held by the address by dereferencing. So it's not two values; it's one value.
So pointers themselves have value semantics. They behave like ints. Pointer, you can think of it, it's just a number that represents a memory address on the computer. In RAM, or might not be RAM, might be whatever, might be on disk. Memory mapped it. But they can be, you can copy pointers, you can compare them with operator equals to see whether they represent, whether they have the same number, whether they have the same address in memory, whether they point to the same thing. You can do arithmetic on them. You can add. You can do pointer to int plus 10, which will move you 10 blocks along in memory, which might be a very dangerous thing to do in a lot of circumstances. You can assign to pointers. You can give a pointer a new value. You can say point to this somewhere else instead. So pointers behave in many ways like an unsigned integer. The special things they have, the special functionality, is they can be dereferenced. So you can say star pointer, which will give you a reference to the thing at that memory address. Dereferences the pointer. And there's also the shortcut of the arrow operator, which is the same as dereferencing it and then doing a dot.
It's not short. It's not short.
It is because of the way operator precedence works in C++. You have to do that. You have to do that, which is horrible to write. So this is not C++. In fact, this is C. So that's why C invented this arrow operator.
It's only cheaper when you've got points to a pointer.
Oh yeah, that's the other thing. So a pointer is just a variable. So you can take the address of a pointer as well and end up with pointer to whatever. Which...
How far can you go before the compiler breaks?
Yeah. And then there's this special value, null pointer, this thing. So where C and older C++ has this null in capital letters that's usually defined to 0, they introduced a new keyword in C++ 11 that represents an invalid pointer, something that is never a valid memory address. So if you are initializing a pointer, you want to initialize all your variables. If you don't have a good value to start off with, initialize it to null pointer. Dereferencing a pointer, so using this star or arrow, dereferencing a pointer that points to null is always an error. So you always want to check for null before you dereference.
Compile error or runtime?
Runtime error, yeah.
What? Shouldn't the compiler be able to check for that since it's
Well, no, because you can change the value of a pointer depending on user input. You can change the thing it points to, and that's the main reason that they're useful. In fact,
static analysis or sample
analysis. There's also this thing called void star. So I didn't say it, perhaps I should have, but I'm sure you all know it. You declare a pointer type with T and then the star. Right, so int star or float star or standard string star. That's how you declare a pointer type. There's this thing called void star. So void is the untype. Void means no type. There's this thing called void star that's an untyped pointer. So any other pointer type can be converted to, any other object pointer type can be converted to a void star. It's really common to use void star in C code. See it all over the place. Fortunately, it's very rare in C++ code. We usually have better ways of dealing with things. Templates would be the main one. There's a new type called standard any that gives you a safer version of void star. But if you're wondering what it is, it's a pointer to which everything can be converted. So that's raw pointers. That's pointers or raw pointers, as they're called. Yeah.
What about the relationship between pointers and arrays?
Pointers and arrays. Okay, so inherited from C are these what are called language level arrays. They're called raw arrays or C arrays or raw arrays. And that's where you'd write something like this. So int array 3 or equals 1, 2, 3 like that. So this is saying array, let's call this variable something else. What should I call it?
R.
Values.
AR. So this variable R is an array of 3 ints. In fact, in the declaration we're technically allowed to omit that and it will get the number from the initializer.
With multi-dimensional, you have to provide the first number with the first bracket, not the second, or the other way around? I never get that.
The last one is the one you can lean into and see.
Oh, okay.
I think. It doesn't matter because I never use them.
You just nest the braces.
Yeah. So this declares what's called a raw array, a C array, a language array, whatever you want to call it. The built-in type, built-in array type. This has a major problem in that this, what's called decays, changes into a pointer to the first element at the drop of a hat. Right, so it makes these C arrays really hard to work with because if I had function foo, which takes an int star, then I can call foo ARR, and that is perfectly legal. That's perfectly fine. In fact, that's the way to do it in C. Because what's happening there is ARR is decaying, is the terminology, it's being converted to a pointer to its first element.
Isn't it already a pointer by itself? You say he's going converted. He's a raw array and basically just a pointer.
Well, it's not quite, because the type of ARR is array of 3 ints, right? So if you want to get really fancy, what you're allowed to do in C++ and not in C, I've got to get this syntax right now because int and 3. Now this is weird syntax, right? Because int and in brackets and then the array arguments. This is how you write a reference to an array of 3 ints.
What's the name for it?
It doesn't matter because you never want to use it, right?
Does it go after after the square brackets?
Oh, the name of the argument would go in there if I'd written it. Yeah, it's awful syntax. So you know what's better? Standard array, absolutely. So my advice, my really strong advice is never ever use a raw language array. Unless, I don't know, if you're dealing with some C code that absolutely requires you to do it, perhaps. But for new code, always prefer standard array. It's no less efficient, but it solves all the problems that language arrays have. So it knows its own size, it can be passed by value to functions, it can be returned by value from functions. All these things don't work for language arrays.
Does that hold true for standard array as well?
No, standard array is fine. Standard array is a regular value type. You can copy it, pass it to functions, pass it by reference, pass it by value. The syntax is very much, is you know, just like everything else. You just say std array of, let's say, int 3 reference.
It's basically sugar around a C array.
It is. It wraps around a C array for you, so it's absolutely as efficient as a C array. There's no overhead whatsoever once you know the compiler once optimization is turned on. No overhead whatsoever, but it behaves much better. It doesn't have this horrible decay behavior. Right. So always prefer standard array to C arrays.
It's also much safer because, like, usually when you're calling C functions, they have two parameters. One for pointer, for what's going to decay, and size. And say you want to pass more data to something, so or less data, so you shrink the pointer, but you forget to update the size. If you just use std array instead, you can never get it wrong because you're going to create the std array with type and the number of elements, and then unless you're really silly, you will take advantage of dot size. So when you call the C function, you pass it dot data, which is the pointer, and dot size, which is the size of the std array. So if you ever come to updating it, you change the number of the template, it's all going to just work because that's going to take care of passing the correct size for you.
But I think it's a bit awful to use if you want to declare multi-dimensional arrays. I think you have to nest them.
You could
that gets a bit ugly. I acknowledge that.
I would do a using statement for those. Once you start nesting types, like, an unordered set of vectors or something like that, then start doing using statements. Like type def. I find using more readable because you're using what I want it to be equal to the type, but it's up to you.
But why did they make it variable with the dimensional types?
Oh, so to have an array of int 3, 4, 5. Primarily because they wanted it to be a simple type. There have been various proposals for a multi-dimensional array or a matrix type or whatever you want to call it. But people always start arguing about exactly what it should do and what it shouldn't do, and whether... the trouble is that these types end up being used in a lot of really high-performance code, and people who write high-performance code have different trade-offs with what they're willing to accept. So, yeah, they've been proposed lots of times, but nobody's ever really come up with an agreement with consensus on exactly how it should behave. We're halfway through, guys.
Oh my goodness.
This is... I thought we were going to race through this in about an hour, and the rest of the time you were going to be sitting here programming. But, well, let's race through the rest of this point a bit, because this was what Tom was asking earlier. Raw pointers still have a use. So you're saying, are they being phased out? Well, no. There was this April Fool's thing that said raw pointers are going to be removed from C++. It's not. They're still useful. They're just not useful to represent an owned resource. Except if you're writing Qt, because Qt is from the Stone Age.
Can we quote you on that?
Qt's memory management is from the Stone Age. Yes, you can. Absolutely.
Somehow I don't fancy. I mean, I'd like to write graphical thingies, but Qt.
So good uses of raw pointers in modern C++ as a sort of optional reference. So C++ 17 or one of the TSs or Boost, they have this optional type. It behaves like optional types in functional languages. But you can't, at least in the standard version, you can't have an optional reference. But you can, and the reason for that is because you can use a pointer as an optional reference.
As a counter argument to that, you could just have an overload. So
Yeah.
if you have a type that's optional, just have an overload that doesn't take it instead. You don't have to pass it, don't.
Second good use is as an iterator for a C array. I'd say that's a good use. I've just told you never to use C arrays, but hey, someone else might give you one. And if you have one, you can call standard begin on it, and the iterator type you will get is a raw pointer. Actually, if you use standard array, the iterator type for standard array is also a raw pointer. And then this is something, when we talked about this months ago, Ollie brought up, you can use it as a sort of rebindable reference in a function body.
What does it mean?
You can reseat it, right? You can make the pointer point to something new.
Oh, okay.
Yeah. However, having said all that, raw pointers are still useful, but as a general rule of thumb, use references when you can, pointers when you have to.
Yeah.
Sorry, what was the rebindable reference?
Well, it's just reseatable, right? If I have object A and B, I can set the pointer to address of A.
Yeah. No, don't worry about it. It's all right. It's all right. Thank you. So yeah, the general rule of thumb, prefer references to pointers, but there are some circumstances in which raw pointers are useful. Brings us nicely on to talk about smart pointers. By the way, I see you two furiously typing. All these notes are going online, so you don't have to, it's probably a bit late to tell you when we'll be going for 2 hours.
To be honest, I prefer to type my own notes. I understand them way better.
Yeah, feel free.
Well,
Feel free
okay, that's me told. Don't feel obliged to take the notes. They will be online. Let's talk about smart pointers. So smart pointers are classes, usually class templates, that have pointer-like behavior, but typically do something more than what raw pointers do, like managing the ownership of the resource. There are two that come with the standard library, unique pointer and shared pointer. And of those, most of the time you want to be using unique pointer. Unique pointer should be your default go-to type whenever you're using, I've said here whenever you need dynamic allocation. That's not true. That's if you need a dynamically allocated array, then you should use a vector. But in terms of if you're dealing with polymorphic types, if you need to create a pointer to a base class that is an instance of a derived class, dynamic type is a derived class, then use unique pointer. Unique pointer is where you should go instead of writing. If ever you think of writing the new keyword, use a unique pointer instead. Don't use new and delete.
I always use make unique.
And C++ 14 gives us this factory function make unique that lets us put in this blanket rule of never use new, which is a really nice, never use the keyword new, which is a really nice nice hard and fast rule that's easy to audit and makes perfect sense until somebody tries using Qt, which has memory management from the Stone Age. But I'll stop ranting about it in a minute.
If your constructor's private, then it falls apart a bit. But
Yeah. There are nice techniques around that.
I think if you just pass new to the constructor of unique pointer, it's no accept, isn't it?
You can, yeah. So yeah, that was the way to do it in C++ 11. But 14, which you hopefully will all be using, is this make unique function. Gives you a bit of added exception safety. Unique pointer is what's called a move-only type. You can't copy it. There's a good reason you can't copy it. It's because you might have a pointer to a derived, you might have a pointer and the actual instance of the thing you're pointing to is a derived class. So you just hold a pointer to an interface type. And if you try and copy that, well, it doesn't know what the exact type of the derived class. So it's not going to do the right thing. And the standard way around that is to have a virtual clone method that would return you a new unique pointer to the base.
Sorry to disturb again the question.
Yeah.
I once had a linked list class.
Yeah.
Or maybe a tree class and had raw pointers in. And I'll convert it to I'll use SD.
Yeah.
And the whole thing became a whole kerfuffle.
In that case, if it was a linked list, what you'd probably want to do is to use unique pointers for the forward pointers, and then if it's a doubly linked list, use raw pointers for the back pointers.
Yeah, it was a double.
Yeah.
Forward would be owning. Forward would be owning. Backwards would be not owning. It's already owning. You've already got an own chain go. It's the end.
I was actually thinking maybe you should just sort out always use shared pointer when you're not sure of the uniqueness.
You need shared for this.
Well, if only someone had prepared a slide with advice for when to use shared pointer, huh?
Also, if someone took your link, depends on the list it is, right? But someone made the end point back to the beginning if you use shared pointer.
Well, you already have one double check. But you work on something. Each of them is something.
You can use shared pointer backwards and forwards.
So unique pointer represents unique ownership of some resource. Typically that resource is memory, but it might be a file handle or whatever. Usually memory is what we care about. Shared pointer represents shared ownership. Shared pointers in C++ are reference counted. So if you copy a shared pointer, it increments the reference count. If you destroy a shared pointer, that's if it reaches the end of the scope. Its destructor runs, that decrements the reference count. And when the reference count reaches 0, the resource is destroyed by whatever deleter function you've given the shared pointer. Typically, that will call delete.
And it's all atomic.
Yes, and these reference, the reference count changes are atomic. However, access to the shared pointer is not.
So imagine two threads get rid of the shared pointer at the same time, right? So you've got two CPU cores doing the get rid of it. So, but there's another thread that's still holding it over here. So you've got three holding it total, two just getting rid of it. A non-atomic operation, right, consists of one call reading the existing value, decrementing it by 1, and then putting it back. Yeah? We've got two threads doing this at the same time. So that means that one will read it, but then the other one's going to read it at the same time. So they both end up reading the value 3. Then both calls decrement by 1, and then both write back. So even though two threads have dropped it, it ends up saying there's two references left. Fortunately, shared pointer doesn't do that, and it implements what's called an atomic, which uses, in the best case, special CPU instructions that prevent it, in the worst case, a mutex. But it guarantees that only one execution call will read, modify, write at one time.
What this means, this reference counting, it means that if you use shared pointers everywhere, if you just go, all right, this sounds great, I never have to worry about memory management anymore, I'll just use shared pointer everywhere, it's going to act more or less like a very simple garbage collector. It's going to, whereas in Java you do new class type, gives you a thing, you can use make shared and it will give you a shared pointer, and then as soon as everyone's finished with their shared pointer and destroyed their copy of the shared pointer, it's going to release the underlying thing. Simple garbage collection, brilliant. Unfortunately, if you try that, you're going to get awful performance. It's not going to work well. Garbage collectors are incredibly sophisticated things. in modern runtimes. But even languages that have built-in ref counting, so things like Python, CPython, and in particular Swift, where the ref counting is built into the language, it lets the, especially in Swift, the compiler do clever things like merging operations and not having to mess with atomic operations when it knows it doesn't have to. So unfortunately, with shared pointer being a library type, the compiler can't do anything special. It's going to do these atomic operations even if they are technically needless. So yes, while you can use shared pointer everywhere and get memory safety, in as much as things won't leak, probably won't leak, you're going to get god-awful performance, so don't do it.
Also, as a point to you, for your idea of linkness, if you make forward points, because I'm imagining, say you want to give access to an object and have the person using it not have it destroyed while they're using it. If your forward pointers are going from beginning to end with shared pointers, that's fine, but then the back ones, the ones going backwards, make them weak pointers. And then they have to.
The other thing that can happen is you get reference cycles. So if A holds a shared pointer to B and B holds a shared pointer to A, then they're going to keep each other alive forever. This also happens in languages that use reference counting, but for example, Python has a special detector for this. I'm not quite sure about Swift. But yes, and there's this type weak pointer that can break the reference cycles if it happens.
Was there any issues with the weak pointer that it didn't?
It keeps the control block alive.
Yeah, I wouldn't worry about it too much.
Okay.
You can go back and watch the video of that talk we did on smart pointers, and we go into a lot more detail about the control blocks and weak pointer and things. This is a guideline. I probably should have put it bold because it's just in small text there at the bottom. Prefer unique pointer. Right, use shared pointer only in special cases, only when shared ownership is genuinely what you want. So don't just do it for convenience, do it because you need shared ownership. And the canonical example of that is when you're passing data between threads. They might finish at different times, you want the resource to go out of scope when the last one finishes. In that case, a shared pointer is exactly the right data type to use.
Even if in a single thread situation, if you have a function that takes a unique pointer, then the only way to pass it back to the common function is to return it as a unique pointer.
I'm not sure I follow.
So if you have a function that calls function foo calls foo A, foo B, foo C,
Yeah.
and you don't take unique pointer,
Yeah.
when you pass it to the first function, you've lost.
Yes. So you'd have to move it into the first function.
It's a share, I get what you're saying. Based on some runtime behaviour whereby you don't know when you'll be done with it because of some external input, say the user closes the window, and additionally you pass usage of the object to somebody else and you don't know when they will be done with it because you're passing it across, I don't know, the function, then it's usually a shared pointer because even though it's a single threaded situation, you just only know the lifetime or the lifetime of the runtime. One main script or the other, just some code paths.
Sorry, two questions.
Yeah.
So for any data structures that have pointers in them, always use unique pointers.
That have owning pointers. This is
Owning.
what I mean.
Oh.
Yes. So if the pointers are non-owning, if they point to a resource memory that is owned elsewhere, that something else takes care of the lifetime, then a raw pointer is the right type to use. A raw pointer, a C pointer, T star. If your class owns that resource, so if you did it manually, if it would release that in its destructor, then unique pointer is usually the right type to use. And very occasionally smart pointer is the right type to use. I said I didn't want this to be 2 hours of me talking, and that's exactly what it's been.
But we're interrupting you.
But we've had loads of great questions, and this is exactly what I thought was going to happen. It's just there's been even more of it, which it's great. Unfortunately, means we're definitely not going to get to the end of all the material, but that's all right. I'll stick it online for what it's worth.
The next bullet point, make shared.
Sorry?
The next bullet point.
The next bullet point is not make shared. There is a make shared factory function like make unique. It's actually more important than make unique.
Yes, exactly.
So if you find yourself needing to create a shared pointer, use this make shared factory function.
And the reason why is because it's the read-only optimization, which puts the control block in the same, it makes a single allocation for everything. So if you say I want to make shared this object is 100 bytes, it will allocate in one go 100 bytes plus however big its control block is, depending on the implementation, right? It's command is 10 bytes. So it just does 110 bytes in one go. If on the other hand you just pass it an existing object and you allocate it with new, great, you've already allocated that, and it's now got to go off and make a separate memory allocation of 10 bytes for this control block, which will probably end up being larger because the OS now is hanging around as well.
I'm still baffled why you want your linked list to have to use two different types of pointers going up or down. I mean, I feel to some
You couldn't use shared pointer in both directions because
That would be a reference cycle anyway.
Because you
would be cycle.
right.
Right, we're going to skip ahead a couple of sections because.
Sorry, not too many questions.
No, that's great.
Our expectation was we won't have any questions.
Yeah, no, it's brilliant. Standard containers. We only talked about this a couple of weeks ago, but for those who weren't here, perhaps watching online who weren't watching a couple of weeks ago, standard library provides lots of them. Vector, list, deck, map, set, unordered map, unordered set. There are different trade-offs between these different containers. So vector has fast iteration, fast access, random access to any of the elements, and you can put things on the back very quickly, but inserting elsewhere into the vector is algorithmically slow. It's order n operation. On the other hand, standard list is a linked list, doesn't have random access iteration, but you can insert anywhere into the list in constant time. Different trade-offs. So know the containers, know the different trade-offs, know what you're getting, use the right type. Standard map or unordered map are the good ones. They're the associative arrays, so what you might call a dictionary in Python or a hash map. Unordered map, it should be called hash map. It's not, it's called unordered map.
I think that's because does the standard guarantee it's a hash? I think it just guarees.
Yeah, it does. It uses one of the template parameters is called hash. It's because Microsoft had an extension that was called standard hash anyway. It's choosing a container. The guideline, my guideline, use standard vector whenever you can. The second guideline, use standard vector. And the third guideline is no, really, use standard vector. We talked about this in a lot more detail a couple of weeks ago, but with modern CPUs, big caches, cache locality is really important, and standard vector gives you best cache locality. If you use something like a list, you're going to be jumping from one location in memory to the next. The CPU is not going to be able to guess your access pattern and load up this data into the cache in advance. Vector is almost always the best performing type to use. Almost always. A couple of exceptions. Use standard string for character arrays. It has the same performance characteristics as vector, but it gives you a nicer API for dealing with strings, obviously. And standard array, where the number of elements is fixed at compile time, and when it's a small number of elements. So you probably wouldn't want a standard array of 1 million ints, because that's going to eat up most of your stack space. But yes, use standard array where you would, if you were writing C, would use the C array. Standard array is a good alternative.
Also So for generally like large objects or anything that's going to get to a stupid size, probably don't want to use vector then.
Yeah.
Or if it's stuff that's not written too frequently, or written quite frequently and almost never, then something like this would be useful.
And just for the last 2 minutes, why not? Just a brief revision from last week. Oh, that's too much. C++11 added these things called move semantics, mostly useful to steal the contents of some other object. In particular, it's mostly useful for objects which use dynamic allocation, which hold pointers to something that lives elsewhere. You can steal that pointer without having to destroy this thing over here or copy it to a new location. You can take it and move it from one vector to another. So things like vector, string, unique pointer. For trivial types, like an int, in fact all the built-in types, a move is the same as a copy. So you can use move operations, does no harm, but it does no good either. Standard move, this is something, the reason I wanted to say this is because I didn't really drum into this enough last week. Standard move doesn't move anything. Standard move marks a variable as available for moving. Sorry? Oh, does it? Oh, god damn it. This is what happens when I... Right, quick edit. Right. This is what happens when you do the slides in a hurry, sat over there. So standard move doesn't move anything. It makes a variable available for moving. It turns we went into far too much detail about this last week. It turns an L value into an X value. So the other reason I want to show this slide, in general, it's a mistake to say return standard move something, right? Where X is a local variable. So it's guaranteed in C++ 17, and it's widely, every compiler for the last 20 years has done this anyway. There's something called copy elision, move elision, means that this will already be optimal. In fact, it'll be more optimal if you don't say standard move. Clang has a really nice warning. I'm not sure if you do W-all, it will actually warn you. Calls it pessimizing move, which is a really, really nice.
Presses the optimization.
Yeah.
Which, if you somehow want that, then of course you can do it.
And again, general rule: once an object's been moved from, it's not safe to use anymore. So trivial types. This is the exception because, as I've said, for trivial types, for int and things, a copy is the same as a move. But most of the time, once you've moved from something, all you can do with it is reinitialize it or destroy it. Whew. Shall we leave it there? We've got 9 minutes to go. What have I got next? R value references. Oof. So yeah, R value references, as I say there, that's what's behind move semantics, that's what makes them work. But you probably rarely need to use them directly unless you're either doing really kind of specialized template code or really trying to optimize something. In general, everyday code, you don't need to use R value references very much. Except move constructors and move assignment operators. Even then, it's better to let the compiler do it, rule of zero and all that.
I got that error message.
That's not the same.
Sorry?
No, that's because it's a trivial type. If you had a function that returns to
So this is the thing, the reason I wanted to show this slide. If you're writing a sync function, which receives an object and stores it elsewhere, so for example in your constructor, you receive it and store it in a member variable. You could do that by R-value reference, and then you'd have to supply 2 overloads, one that took a const ref and one that took an R-value ref. Most of the time you don't need to do that. You can just take the parameter by value, you'll get move semantics, you'll get optimizations. So a sync function passed by value, and it is almost never necessary to declare a local value of local variable of R value reference type. If you do it, all you're likely doing is lifetime extending a temporary anyway. You may as well just use an ordinary non-reference object. As with all of these things, I've written in general, usually. It means there are exceptions. There are exceptional circumstances. This is C++. Stuff is complicated. There are exceptions to every rule. Ollie delights in telling you the exceptions to the rules.
Yeah. And then explaining when you should do it.
But that's it from me. I put this optimistically. Ask us anything. I mean anything related to C++.
What about the values casting?
The various casts.
Yeah, cast.
Okay, there are
3.
5.
Well, he's talking about static reinterpret.
Yeah, and the other one?
Yeah, there was.
There are 5 kinds of casts in C++.
I don't want to go into C stuff.
Right. A static cast. The static cast does a compile time check that it's okay to transform one type into another.
Probably.
Yeah. So if you try to static cast a string into an int, that's not going to work. It's going to say no, I don't know how to do that. That's an illegal static cast. Dynamic cast does mostly the same thing, except that it does the check at runtime instead of at compile time. And dynamic cast can be particularly useful for casting a pointer from a base class to a derived class. So you can always convert a derived pointer to a base, and dynamic cast lets you go the other way around. And it checks that at runtime. It uses something called runtime type information. It makes sure that that cast is okay, and if it's not okay, it'll throw an exception.
Also note that if you dynamic cast to a pointer to the type, and it can't do it, it just returns another pointer. If you cast to a reference, then it will an exception. The third kind of cast is Const Cast, which can be used to add what are called CV qualifiers, so const and volatile. You can remove these markers. Generally using Const Cast is a good sign that you're hacking. I've only ever used it to work around the stupid C library.
Yeah. Using Const Cast is a good sign you're either doing something wrong or you're trying to be much too clever. Right? Const Cast is a way around. We said it kind of that casts puncture a hole in the type system. Const Cast is a way of puncturing a hole in const correctness, which is probably not a good thing to do.
And there's no guarantee that what you're doing is actually not wrong. Like you can const cast up and it may be completely UB. You might end up trying to write to data section.
Yeah.
Executables, read only, will just crash all.
Yeah, if you try and const cast on a variable that was in its initial declaration declared const, then that's undefined behavior. Anything can happen, all bets are off. The last kind of C++ cast is Reinterpret Cast, and that literally says take the bytes of this thing and pretend it's the bytes of this thing. Right? Reinterpret Cast is in many ways the most powerful of the C++ casts. It's really good for doing low-level stuff. If you're dealing with, raw device drivers and things, you'll want to use Reinterpret Cast. In general, because it's the most powerful, it's the one you want to use least often. Even more rarely, I would say, than Const Cast. No, that's not true. There are legitimate uses for Reinterpret Cast. There are no very few legitimate uses for Const Cast.
The only time I ever used it is arrays of buffers from libraries.
Yeah.
Signed type, I want unsigned.
Valid uses for Reinterpret Cast. For example, if you're serializing something, it's legal to look at the bytes of that thing as if it was an array of unsigned car or an array of standard byte. That's a legitimate use of Reinterpret Cast.
Don't reinterpret cast classes never as well. It happens to work.
So that was for the last one, what are called C casts. These are the ones inherited from C. That's not really a kind of cast by itself. What it'll do is it's
in round brackets, yes, the one.
yeah. So you do type in brackets and then the variable name, or you can do it the other way around in some circumstances. You can do and what that'll do is it'll try the C++ casts in various order. Basically, try very hard to make it work.
So it's not an actual C. It doesn't do a C cast directly.
It does the equivalent of what C does, but it does it in terms of it's defined to call these C++ casts in different orders to try and get it to work.
Ultimately, it will try reinterpret cast.
Yeah.
So it will give that a go. So if that doesn't work, then it fails C.
Yeah.
With the cast, does it make a copy?
No.
Const Cast doesn't make a copy. Well, it can't. So now we're going to make a copy, right?
Casting returns an L value reference to the type, or reference. Could be an L value reference as well?
No, it can return a PR value if. So it depends on the type you're casting to. If you're casting to a reference type, that won't create a copy. The static cast thing in brackets. If the thing in brackets is all right. What? I know we're going to get kicked out in a minute. If people want to get off, that's fine. If I were to do. So again, imagine this was all on one line. But if I have this thing, hello, and I try and static cast it to a standard string, that's going to work perfectly fine. That's going to call the standard string constructor that takes this, and what this is going to return me is a PR value standard string. So this line is exactly the same as if I called the standard string constructor directly. Right, so yes, in some circumstances it can return you a temporary, which is what you asked. So there you go. Yes, that's it, thank God. Anybody who wants to get a head start or a bit of practice in, go back, look on the website, the GitHub. We had this noughts and crosses exercise. I think it's pretty good. I don't know, Tom and Laurent and Joshua might remember it. We did it as a group thing at the time. You're all a bit more advanced now, so I think taking it on by yourself should be reasonable. And that is it from me. 9 o'clock on the dot.
Thank you very much, Tristan. Really appreciate it. It was, I think I can say for everybody, it was a massive, amount of material covered. I think you felt like you passed this. You deserve the certificate. Again, really appreciate it. Thank you very much, Oli as well for assisting. So now what's going to happen? We're going to pub. Everybody's welcome to join us, have a pint and so on. Pay respect by beer to these guys for their time. Tristan, maybe even more than one. Next session is with Phil Nash. So we're talking about a really nice guy, author of very popular testing environment. Thanks to him, we got the Sea Lion licenses as well. So you're very welcome to come in, spread the word. And very important, send me suggestions for projects. Yes, if you don't send me, I will make sure you will regret that. I will come out with ones and then you'll be swearing, but it won't be my fault. So without actually taking more time and stopping you from getting a pint, thank you very much and see you next week.
Thanks, guys.
ask a dumb question? I remember this one. Next week.
Yeah, go on.
Is it worth knowing sort of the internal structure of the way C++ organizes?
I mean, is it one project?
Do you want to take it seriously now?
I've seen people show how you can actually call the method.
Hold on, I thought we need to supply this around the actual type of the project.
No. So that.
Oh, then I didn't. So
Yeah, absolutely. So the layout of objects is what's called implementation defined.
there is no network.
So
No.
no. So in general, I wouldn't worry about it. You can have these things called member function pointers, but they're horrible to use. Avoid them if possible. Yeah. I would say unless you're doing very specialized stuff, I wouldn't worry about it. No.
Yes, guys.
Yeah. Heading off home? Yeah, no worries. Don't worry about it.
Thank you.
I think I'm
No worries.
starting to get some
See you next Tuesday. See you next week.
Yeah, don't stop saying that to people. Yeah,
I'll be back to doing
the material that we've had is all on our GitHub, so it's
And
github.com/CPP London Uni. We've got all the past lecture slides on there. These slides will be going up, and yeah, please do join us in a couple of weeks or next week if you're free. Yeah, it'd be great to see you. Sorry that you've jumped in the deep end.
Yeah, no, I just saw it on the
Skills Matter
rather than on your website.
Okay.
I
Wonder what that is. Yeah.
Yeah, so no, that's good.
I mean, yeah, if you do any stuff with unit testing, we're just interested in it. Come next week anyway, because it will introduce you to one of the greatest frameworks out there for C++ for doing it.
Is that the first point in the course when you introduce unit testing?
So it's not. This is a special guest who we were going to have at the beginning of the month, but then he couldn't do it, and so he's doing it next week. But it was more like we're just doing this special event, basically.
So it's not that happens, frequently that you get an author of a very, very popular program to come and teach us how to use it. So it's exception from the norm.
Yes, someone can do.
Tristan, how are you feeling?
Knackered.
Yeah, you look knackered. But I mean, look, if I would cover that kind of material, I would be dead.
Sorry?
If I would cover that kind of material, I would be dead.
It actually was the most engagement I've seen for a bloody while. Like, it actually got people asking questions and like this, that.
Yeah.
So I thought that was
That's good.
Because it was easy to pick on poor Tristan and test his thorough knowledge of C++ if he's not pretending.
Yeah, I've been making it up so far.
So definitely you don't have to have the what's the syndrome? Imposter syndrome, yes.
I think we've got enough experience now that that's gone. I don't think there's the imposter syndrome anymore.
I don't know. I don't know if you. I don't know if you frequent the standard name list.
How's your day been, all right?
Yeah.
Forget your phone. That's right, just put it there and get it. Thank you, sir.